Good morning, students. Today I am going to discuss few questions in the worksheet from the worksheet. Now, the without wasting time, let us see first question. Why do passengers tend to fall sideways when the bus takes a sharp turn? Whenever you have seen that whenever a sharp turn of the is taken, the passengers always fall sideways. So the reason behind that is the inertia of direction. So whenever the bus takes a sharp turn, the passenger falls due to inertia of direction. Okay, while the passenger bus is moving, the passengers exist, the inertia of motion in the direction of the bus, but when the bus takes sharp turn, the body of the passenger opposes the change, and hence then they tend to fall sideways. Now the second question is, why are road accidents at high speed very much worse than accidents at low speed? It is seen that we have to always limit our speed while uh, riding a bike or any vehicle. This is due to momentum. Okay, so the reason behind this is due to momentum. Road accidents at low speed cause less damage, and at high speed the damage is very large. You know that momentum is mass into velocity. If this velocity is very high, then the momentum will be large and the damage will be large, and if the velocity is low, then the momentum will also be low and the damage is less. Now next question is, name the action and reaction forces acting during rocket propulsion. We have seen that in rocket propulsion, the action forces, the hot gases produced by the rapid burning of fuel, rush out of a jet at the bottom of the rocket at a very high speed. I have already explained in one of my video the functioning of rocket. So the hot gases, they are the action force, and the reaction force is the equal and opposite reaction force of the downward going gases pushes the rocket upward with a great speed. Okay, so these are the action and reaction forces. Now next question is, why do we have to run in the direction of the moving bus while getting down from the bus? We have to run while getting down due to the inertia of direction, otherwise we will get hurt. Okay, why does an electric fan continue to rotate for some times after the current is switched off? Again, inertia of motion is there. Due to its inertia of motion, it resists to be in state of motion unless some external forces applied to stop, that is air resistance. So it takes some time to stop the blades. Now next question is, a person hit harder when falls on the concrete floor than when he fall on a heap of sand from the same height. Why? When a person falls on a concrete floor, he hit harder because he is brought to rest in a very short time, as a result of which a greater force comes into action in a very small time. Whereas in the case of a sand, if a person falls, he takes an short interval, but more than that of a concrete to come to rest, and hence less force comes into action, and this the person gets less hurt. So force applied is inversely proportional to time. You know this relation. Now next question is, two identical bullets are fired, one by a little rifle and another by a heavy rifle with the same force. Which rifle will hurt more and why? We know that force and mass of the bullet is same. So by Newton's third law of motion, every action has an equal and opposite reaction. So the lighter rifle will move more quickly in the backward direction, that is recoiling velocity of the light rifle will be more, and that so causing serious injury to the shoulder. Now next question is, it is difficult to balance our body when we accidentally step on a peel of banana. Explain based on Newton's third law of motion. We know that the banana peel reduces the friction between the foot and the ground, Okay, it makes the ground slippery. As a result, low force is applied by our feet on the ground. As a result, the action force is also less and we cannot make balance and slip. Okay, now next question is, a bullet fired against a glass window pane makes a clear hole in it, but a stone smashes the glass pane. Why? With a bullet, time duration is less, so force applied is more, which makes a clear hole, while with a stone the time duration is more than that of the bullet. So force applied is less and then that of the bullet, so it smashes the glass pane. Now next question is, define inertia. How does it depend on mass of the object? Explain. These are the application: dusting of a carpet and removal of water. We know that inertia is that property of a body due to which it resists a change in its state of rest or of uniform motion. Now dusting of carpet by beating it with a stick makes the dust particle come out because the force of the stick makes the carpet move to and fro slightly, but the dust particle tend to remain at rest due to inertia and hence separate from the carpet and fall down. Similarly, for the removal of water from the wet cloth, when it is squeezed, the water tends to remain at rest while the particles of the cloth get squeezed, and so water comes out from the cloth. Okay, now next question is, a ball is suspended by a cord from the ceiling of a car. What will be the effect on the position of the ball if the car is moving with constant velocity? It is in accelerated motion and is turning towards right. There are three cases and it is given that the ball is suspended by the cord. Let us see the first case. When the car is moving with constant velocity, we know that if it is moving with the constant velocity, then the jerk will be less and the ball will remain stable and it will be vertically tied with the cord. Now next is, the ball will move in the opposite direction of accelerated motion. Wherever the accelerated motion is there, the ball will always tend to move in the opposite direction. Similarly, if the car is turning towards right, the ball will move towards left, that is in the opposite direction. Now next is, give reason and give the law related to these statements. It is easier to push an empty box than a box full of books, and it is difficult for a fireman to hold a hose which ejects large amount of water with a higher velocity. Let us see the first case. It is based on the law of inertia. The frictional force of an empty box is less than a box full of books. We know this. Okay, so it is easier to push an empty box than a box full of books. This is due to the frictional force, and here law of inertia is applied. Now second one is based on the Newton's third law, that is force of action due to the ejection of large amount of water is much larger, due to which the reaction force to hold the pipe becomes much larger. As a result, it is difficult for a fireman to hold a hose pipe. Now next question is, the state and prove law of conservation. It states that when two or more bodies act upon one another, their total momentum remains constant. That is, before collision is always, momentum before collision is always equal to the momentum after collision, provided no external forces are acting. Now for the proof, we have to consider, let two bodies, a truck and a car, is taken having mass m1 and m2 and both are having different velocity. So let u1 be the initial velocity of the truck before collision, so its momentum before collision is m1 u1. Similarly, if the mass of the car is m2, initial velocity is u2, so the initial momentum of the car will be m2 u2. So the total momentum of the truck and the car before collision is m1 u1 plus m2 u2. Similarly, after collision, their momentum will be m1 v1 and m2 v2. So total momentum after collision will be m1 v1 plus m2 v2. Okay. Now suppose during collision, the truck exerts a force F1 on the car, and in turn the car exerts a force F2. So when a force F1 of the truck acts on the car for a time t, then the velocity of the car changes from u2 to v2. So acceleration, we know that A is equal to v minus u by t, and force is mass into acceleration. So F1 will be equal to m2 into a2. Substitute the value. Similarly, when the force F2 of the car reacts on the truck, then the velocity of the truck will be m1 into a1. So by Newton's third law, F1 is equal to every action force has a equal and opposite reaction. So substituting these values, we get the conclusion of the momentum, total momentum before collision is always equal to the total momentum after collision. Now let us see in the diagram below, a 1 kg mass of a rough horizontal surface is joined to a 2 kg mass by a light inextensible string running over a frictionless pulley. Will the 1 kg mass move at a lower, higher or zero acceleration? We have to identify, explain based on the Newton's law of motion and state the law. The 1 kg block is there, it's 2 kg block, this is the frictionless pulley and the string is tied here, and this is the rough, slightly rough surface. So we have to see, by Newton's third law of motion, every action has equal and opposite reaction. So 2 kg weight having more mass will pull the mass of 1 kg with the help of light frictionless pulley, and it will get accelerated at higher acceleration, ignoring the rough surface. This is your solution. Now next question is, a bullet leaves a rifle with a velocity of 100 meter per second, and the rifle of mass 2.5 kg recoils with a velocity of 1 meter per second. So we have to find the mass of the bullet. We know this formula for the recoiling of gun, that is momentum of the bullet is always equal to the momentum of gun. So we will substitute the value and the mass of the bullet will be 0.025 kg. Now next is, a cricket ball of mass 0.15 kg is moving with a velocity of 1.2 meter per second. We have to find the force applied by the player if he is able to stop the ball in 0.18 seconds. Okay, so the ball is stopped. Now we have to see this, mass of the ball is given, initial velocity is given, force we have to find, final velocity will be 0 and time is this. So we know that F is equal to m into a. For that we need to find a first. We will find a by Newton's first law of motion, and we will substitute it in F, and thus F is equal to 1 Newton. Now next question is, two bodies of mass 1 kg and 2 kg moving in the direction opposite to each other collide with a speed of 5 meter per second. Okay, now we have to calculate the total momentum of the system before collision. So before collision, the formula is m1u1 plus m2u2, mass is given and velocity is given. After collision, their momentum will become m1v plus m2v, since the velocity will be same because they have collided. So after substituting the value, we get total momentum before collision is equal to 15 kg meter per second. Okay, now let us see next question. A speedboat has a mass of 500 kg. It starts from rest and travels through 200 meter in 12 seconds. The boat undergoes constant acceleration during 12 seconds. We have to find the magnitude of unbalanced force acting on the boat. Whatever is given, we will write down first that. We have written mass of the boat, initial velocity, and then distance travelled, then time taken. So for the unbalanced force, we need to find acceleration and force. Again, we will apply Newton's second law of motion, S is equal to ut plus half at square, and substitute in the force formula, and thus we will get the force as 1388.88 Newton. Now next question is, a motor car of mass 200 kg is moving with a certain velocity. It is brought to rest by the application of brakes. Retardation is there within a distance of 20 meter. When the average resistance offers to it is 500 Newton. Okay, so what was the velocity of the motor car? So mass is given, retardation is there, so V is equal to 0, S is equal to 20 meter, and the resistance force is there, so minus 500 Newton is there. U we have to find. First we will find the acceleration and we will substitute in Newton's third law, and thus we will get initial velocity as 10 meter per second. Now next question is, a man throws a ball weighing 500 gram vertically upwards with a speed of 10 meter per second. We have to find the initial momentum, its momentum at the highest point. Mass is given, it is in terms of grams, so we will convert it into kg, and initial velocity is 10 meter per second. So the initial momentum will be mass into velocity, that is 5 kg meter per second. Now momentum at highest point. So the ball, once it reaches the highest point, the velocity will be 0. So the momentum at highest point will be 0. Now next question is, the velocity of a body of mass 10 kg increases from 4 to 8 meter per second. And when a force acts on it for 5 seconds, find the momentum before the action of force, after the action force, and the magnitude of force. Mass is given, U is given, V is given, T is given. So the momentum force, the action of force will be m into V, that is 40 kg meter per second, and after the action of force it will be m into V, that is 80 kg meter per second, and the magnitude of force will be V minus U by T. First we will find the acceleration and then we will substitute, and it will be 8 Newton. Now next question is, two blocks of mass m1 and m2 are placed in contact on a frictionless horizontal surface. A force of 10 Newton is acting on m1. What is the acceleration and the magnitude of action and reaction of forces? F is 10 Newton, mass is 1 kg, m2 is 2 kg. So jointly their mass will be 3 kg. Since they are in contact with each other, so the acceleration acted will be 10 by 3 meter per second square. So magnitude of action force is 10 Newton and magnitude of reaction force will be 10 Newton if the blocks are stable, that is not moving, and if it will be greater if they are they move on the frictionless surface. Now last question is, a force 40 Newton acting on a body of mass 10 kg changes its velocity from 5 meter per second to 25 meter per second. Determine acceleration, time for which the force acts, and the distance covered. F is 40 Newton, mass is given, U is given, V is given. So we will find first force, that is A is equal to F upon N. So it will be 4 meter per second. Then we will find the time by this Newton's first law of motion, it is 5 seconds, and then by Newton's third law we will find the distance. Thank you.